unless you explicitly say object action, but that's also possible. Usually it's JVM as an object action. So you do that for how, but you still have a way to manipulate the object action collector to do the object action for you. You don't have those kind of data. So you give the space for that long data process.
Hello. Hello.
Shall we start? Because there is, what time they start having impact on the parking fee? Because they say that after a certain hours, parking fee How far from here? It's like corners.
Hey guys, thanks for coming down tonight. Just give me a second. So, thanks again for coming down tonight. Today a great talk on HBase. Before we do that, just a few announcements. So, as you know, many of you have probably noted, today we sent out an invite for the LA user group holiday party. It's the first time that several user groups in LA are getting together in this holiday party. We have probably about 15 user groups. It's completely free. Again, we need to RSVP before the event fills up December 1st. Also, just a few more announcements. On December 4th, we're going to have candidates from Hortonworks who's going to come and talk about Stinger next. That's going to be a great talk. So, it's going to be again factual. Hopefully, a lot of you can make it for that. Next week, we have another meetup, and as well as the week after, we have a Spark meetup at DirecTV. Just a few more announcements. Databricks, again, it's probably about 90% confirmed. Databricks, the founders or creators of Spark, will be coming down on December 11th to do a talk. As soon as they confirm, I'll send out an invite about that. So we have a great number of Spark Talks in the next few months, so you should attend those. Finally, I just want to introduce Nick. He's a committer on HBase. I've known him about a year for now, and he's a great guy. Today, he's going to talk about state of Apache HBase. Nick also works at Hortonworks, so I was just talking to him, and he's actually working on HTTP 2.2. So that's going to be a really great release, and Spark, Nox, and just everything in between. If you can't just wait for that, let's talk to Nick and try to give him some, ask him for the beta access right now. We need that. All right, Nick, come on board.
Excellent. Hi, everyone. My name is Nick. Like Marsh said, I'm a HBase developer at Hortonworks. I'm an HBase committer. And, I'm here to talk to you a little bit tonight about the up-and-coming HBase 1.0 release. So this is a big deal for me, having been in HBase for a while, so hopefully I can share some of that excitement with you guys. Now, give me some context for the room a little bit. Who's heard of Hadoop? We'll start there. I think everybody, should be a lot of hands up, so keep them up now. Who's heard of HBase? Familiar with NoSQLs? Okay. You've been playing with some HBase, you know some Roki design ideas, you've done some schema modeling, this sort of thing. Okay. And you've been running HBase in production for 2 years, and you'd like to take me out in the back and have a conversation later with your buddies. Okay. All right, very good. That helps me see where we are. So, as I said, this is 1.0 release for HBase. It's a culmination of a lot of work for the community over a number of years, and I'm going to share with you some of that history. So, this is both a big deal in a kind of milestone release sort of way, and it's also just another release. So it's a little back and forth. Just another release, and that like any release of a database that's ready for production, we're targeting our primary goals for the release are things like stability, reliability, and performance. So, and I'm speaking here on behalf of our release manager for this release. So if you have actual questions for the 1.0 release that I can't answer, then Dennis is the guy who can help you there with those questions in the mailing list and whatnot. So my topic for tonight, we'll go over a little bit of the history of HBase, and I want to tell you a little bit about what HBase actually is, give you some context for those who aren't as familiar with HBase, because I'm going to talk about the new features that are coming out with this release, so it helps to understand a little bit about the system, to have some context for what those features actually are and why they're good and important. And then I'll walk you through what it'll take to take your existing cluster from whatever HBase version you have deployed today up to 1.0. Okay, so any questions before we begin? Nobody wants to fill in the front rows here? All right, fair enough. So yeah, do feel free to ask questions along the way though, okay?
I'll take it up.
Awesome, thank you very much. I feel less lonely now. Okay, so I've broken down kind of the history of this HBase project into 3 pieces. So the first one I'll talk about here is called the early years. HBase is designed after a system that Google has run in production for many years. So they wrote a white paper about this system, and the system is called Bigtable. So HBase is an open source implementation of this system that was described in that paper. So HBase started life as a little code drop into this young project called Hadoop. It was a contrib module in Hadoop. Detail of HBase is it requires Hadoop distributed file system to run, so it made sense that HBase would ship alongside Hadoop. So the early versions of HBase were actually tightly coupled to Hadoop versions. So first HBase release was actually Hadoop .15, which was some time back. As Hadoop grew, HBase grew as well, and eventually the project separated into its own sub-project of Hadoop, so it was no longer tightly coupled, shipped from the same source, but all those releases were going hand in hand with Hadoop releases. Around 2010, HBase actually splintered off and became its own Apache project. This is around the same time that HBase started to see real production deployments in places besides the original startup that had written the initial code. It's in this sort of timeline that companies like Facebook and eBay are picking up HBase and starting to use it for real production workloads. So we also started versioning our own self. So we had some independence from the from the Hadoop distribution upon which we ran. So you could run. We chose HBase 90 with this release in mind, right? The idea is we're working our way toward 1.0. So we had this idea of 1.0 way back in 2011. It's taken us a couple of years to get here, but we're finally coming. And also, as HBase gained more popularity, you start to see some books show up on the shelves. We have our first conference. My book is one of those. I'll give it a plug at the end if you don't mind. And this is when the community is really growing as well. So our number of folks who are participating in the mailing lists and contributing code is increasing through this period. So then the next bit, right, is modern HBase. So this is now, HBase has really come into its own. There's a lot of production experience. We learned a lot of hard lessons from those first foray into production. The HBase 0.96 release was a big deal for us. We took a lot of those lessons learned and baked those into that release. So in many ways, I think of the 0.94 release as our actual 1.0. That was very production stable and heavily used. It's still that branch is still actively maintained today. There's not new feature development happening there, but plenty of folks are in production with 94 and continue to be in production with 94 despite the more recent releases that we've had. So going from 94 to 96 was a little bit of a painful process because it required to take some downtime. We couldn't do a rolling upgrade for that one. But that allowed us to make some breaking changes that will further enable development of new features and continue the evolution of HBase. So that was there's a lot of new features packed into 96, and then they hardened in 98. We had continued to have Apache HBaseCon, which is a great conference. It's one of my favorites, and I mean, I'm a little biased, but I like a good tech conference, whatever it is, and still I get a lot of bang for the buck, I think, out of HBaseCon. And then an interesting project, right? HBase is a NoSQL storage system, but this project comes along actually coming out of Salesforce called Apache Phoenix. So this is a project that's putting SQL back into HBase. So it ships as a fat JDBC driver that exposes HBase tables through a SQL interface. So Salesforce is using this basically to replace a whole bunch of database deployments that they already have with a particularly overpriced vendor. So all this, we're finally here, end of 2014, leading up to and ready for the 1.0 release, and hopefully the momentum will continue, and we'll see a 2.0 release not so far from now. All right, so what is HBase? So let's fill in some of that context, like I promised. So HBase, I think of HBase as a database, right? It's an online database. It's a strongly consistent distributed database, which carries a lot of, packs a lot of material into that statement. For any of you who are familiar with distributed systems, the idea of maintaining strong consistency is a shall I say, strong guarantee, and that comes with it certain trade-offs that are made in a distributed system. It's range partition storage as well, which is how it manages to distribute itself across the cluster. But starting from the outside in, this is a summary of the HBase data model. So in HBase, you define your table, just like you would in a relational database, and your table has rows. Inside of a row, things are a little bit different. We have columns, just like you do in a relational data store, but our columns are more like a hash map, something like this, a dictionary, nested map of maps. So we have this concept of a column family, which is a container for column qualifiers. So the combination of column family, column qualifier is the coordinate at which you can find a bit of data, your value. If you think of it as a key value store, where row key, column family, column qualifier all point to a value, you can think of it that way as well. those values themselves are also versioned. So you have a timestamp column there in the coordinate system you can see, and that's exposed to users. If you don't specify a timestamp, the system will assign one for you, but you can also use that yourself and include that as part of your schema. So it's a NoSQL and it's generally considered schemaless. The only thing you have to define when you're telling HBase you want to have a table, you have to give your table a name and you have to tell it what column families you want to have, because column families are a hook for you as a system administrator for defining physical properties of the data organization and layout. But inside of the column family, you have higher complete freedom and leeway to do whatever you want. So I have a couple examples up here. So for instance, there in row A in the first column family, you see foo has 3 different versions there, right? And 22, 13.6, and that string world are not the same same types, right? So HBase doesn't care what you store in it. It treats everything as byte arrays, except for the optional data typing API, which we do support. But traditionally, HBase is thought of as a schemaless data storage system, and that's facilitated there. The other thing I'll point out here is even specifying column families, you don't have to use them, right? So A has data both in column family 1 and column family 2, B does not, and that's entirely up to you. Questions about? Yes?
When I design this kind of key value schema, sometimes like, for instance, in this, we describe something, usually has some kind of measurement units. For instance, we say food, then you say colon qualify is a drink, so I say Coke. But in the Coke, they have ingredient, you say how many, how many is sugar, sugar is how many kg. You know, in the United States, we're still using some kind of weird measurement units. So my question, when I want to represent these measurement units, such as kilogram, centimeter, feet, what's the best way to put it? Because this thing is always repeat, right? It's like if this food ingredient is 100 kg, this kg, if 100 put the value kg as suffix on kg, is my space is get repeat a lot.
Yeah, you'll always have that.
So I want to take away this kg. I feel this way is much natural for me. Okay, this row, where is the best way to put this measurement units?
So you can, if you have these measurement values of multiple units, right? So maybe you're measuring sugar in both grams and ounces. You can put those into the column qualifier, for instance. Right? Okay. You'd still be repeating, but it's attached to the qualifier where it's accessible that way. If you're concerned about repeating data, you can write this data as you have it, but you can look at some of the optional kind of more advanced functionality of HBase. So one thing you can do with a column family is you can specify a block encoder, and there's different encoding algorithms. But the idea of these encoding algorithms is that they store the key value pieces in a more optimal way based on some knowledge or information about the shape and the regularity of those, in those cases of qualifiers, for instance, right? So things like fast diff encoding or prefix tree encoding will allow the system to not repeat that unit over and over again based on its use, right? If it's, I don't have any slides on this, I'm afraid. I can try to explain it maybe. So there are some tricks like that that you can use to avoid duplicating the data in terms of actual storage on the disk.
Do you not need to specify the type of the value? I see like you have a number and a string in the same column qualifier.
Yeah, there's no need to specify a type. HBase, in fact, when you use the API, the low-level API, the default API today, you give it just a byte array. So you have to manage converting from integer, from string, from whatever your application level type is into a byte array for storage there. So you can do that directly. HBase provides some utility methods for some common encodings. You can also, sophisticated is maybe a strong use of the word, but you can use, there's existing tools like Portabuff or Avro or Thrift, these kinds of systems that are, in which you can define structure and encode, and they do the encoding for you. So you can, in the case of Avro, for instance, it will serialize the schema along with the values so that you can read it back out again, even if you don't know exactly what's in that cell. But there's, just as a basic point, you're just putting a byte array into HBase. That's all it sees. One more?
Tell about best practices for table design.
That's a talk in and of itself. I don't think I can give that in 5 minutes.
Rules of thumb.
Design based on your application's access patterns, not based on entity modeling or something like this. You're used to denormalization in a relational database, and those concepts don't really apply in a distributed NoSQL store like HBase. So one kind of trick you can play would be to model out your system, describe your entities and their relationships in MySQL, put that schema there, write your queries, and then look at the explain plan. See where it's telling you that you need to have indices and that sort of thing. And those guides will be a suggestion for what you should put in row key and maybe what you should put in column qualifiers and so on. That's one little trick I guess I can share with you. One other thing I'll point out before we move on to the next slide is that HBase is also a sorted data set. So A coming before B, CF1 coming before CF2 is intentional in this diagram and the timestamps as well. So that's a guarantee that HBase makes for you is that it's storing your data ordered like this. And you can use this fact to write queries that are not just a single random row key access, but to execute a range scan across a number of rows. So you can scan A through F, and HBase will allow you to do that very efficiently. So when people talk about writing HBase queries, this is a common use case, not just the random key value store that other NoSQL systems like maybe React are designed for. It's this row key scan is very powerful for HBase and HBase schema design as well. So we have our table, and the rows of the table are ordered according to their row key, as I described. So HBase takes those rows and takes those tables and it partitions them, and in HBase we call those partitions a region. So a region is defined with a starting row key boundary and an ending row key boundary, this kind of thing. So you see the table A here in this example is broken up, region 1, 2, 3, 4, and then the distributed system, distributed rigging of HBase takes those regions and it distributes them around the cluster. So there's a component of HBase called the region server, which its job is to host regions, to serve regions. And so this is what it does. HBase will automatically take regions and balance them across the region servers in your cluster. So you don't have to manually manage the distribution of those partitions, those shards around the cluster. You can define the shard boundaries if you like, but if you don't want to do that, even HBase will take care of that for you as well. So when I was first studying the sort of NoSQL landscape, I was looking for a solution to my data problems, and I decided that HBase was going to be that solution. This is this automatic management of the distribution of data was very exciting for me, right? Because I had just gone through the process of sharding on my SQL database and distributing my application queries across the shards. It's kind of a nightmare, right? So HBase will do a lot of this for you. It's also very tunable, so you can override any of these decisions that it's making. But out of the box, this provides you with a lot of power for management and actually not managing the data, right? Letting the system do it for you on your behalf. And there's not necessarily any rhyme or reason as far as which region lands on which region server. HBase will do its best to balance the load. You can always do better at that, and you can even override the balancing decisions according to the nature of your application if you want to do that. It's, again, kind of more of an advanced feature, but like I said, basically every decision that HBase is going to be making for you, you can override and influence based on your application if you like. So any questions on this bit before the last of this. It's been a few more than 5 minutes. Okay. So then the last slide, in terms of what is HBase, is a physical architecture diagram. So like I said, HBase depends on Hadoop, and it runs on the distributed file system, HDFS. So that's what you see there in red at the bottom. Hadoop HDFS consists of 2 types of processes. It's maybe hard to see at the bottom from the back, I apologize. But there's the data node is a process that handles actually storing the data in the distributed file system. And the data nodes are orchestrated by a name node. HBase has a similar kind of architecture where those region servers, host the data, host the regions and make it available online. And then their distribution around the cluster and their orchestration is handled by a process called HBase master. So that's what in the blue at the top there. And then HBase uses Zookeeper, another Apache project, again, based off of a Google project, that service that they wrote a white paper about. HBase uses Zookeeper to handle the online state of the cluster. Nothing permanent about the HBase cluster is stored in Zookeeper, but its online operations are coordinated through Zookeeper. So we take advantage of Zookeeper for that purpose. And then finally, the client. Distributed database or any database, the client is also part of the system. This is no different. In HBase, the client will talk directly to the region servers. So if your client sits in the same network region as your region servers, you'll see benefit from that, right? Because the client is opening direct connections to the individual region servers that are hosting the partition of the data of the table that they're looking for, right? So they will locate the region. You're looking for table A, region 3. The client will go figure out which region server is hosting table A, region 3, and then it will go talk directly to that region server. So you get full bandwidth of communication to that server from the client. Any questions here?
Can you guys rewritten the HBase client soon? Because I've dealt with that. I've noticed it swallows a bunch of errors and things.
Swallows errors. That doesn't sound good.
It isn't.
HBase client has seen some attention in the 96 timeframe. I don't know what version of HBase you're using in the past, but we did a lot to make the client asynchronous under the hood. So the implementation, the client API that you see is still synchronous, but the communication of the client to multiple region servers to handle reads and writes is made asynchronous internally. So I don't know if I call it swallowing exceptions or swallowing errors. What it's trying to do is to smooth over pockets of unavailability. So I haven't really talked about consistency versus availability or any of that topic yet, but a region is available and hosted online by a single region server, right? So if for some reason that region server goes down, the system needs to bring that region back up in another region server. It has to change ownership. And so the idea is to be able to have the client transparently handle this for you, right? So a region is being moved from one region server to another. The client will see that this is happening, and it will wait for the region to come back online without interrupting other write operations, read operations for that matter, that are going against the cluster at the same time. Make sense?
Talk the data consistency and the integrity. Let's say the regional server has multiple data nodes, manage multiple data nodes. Is there some built-in mechanism in the HBase? I say my data nodes is totally, for whatever reason, gone. So is there a way to replicate my old data in the data nodes?
So HBase doesn't manage the data nodes. HDFS is managing itself. HBase is taking advantage of HDFS and is co-located. I've drawn the region servers sitting on the same host as the data nodes themselves, so that when a region server is accessing data that's available on its local disks, it's able to bypass the network operation and all that stuff and go there. If, say, the region server is up and it's online, but for some reason the data node process on its local machine goes away, it's still using the HDFS client API, which means it's going to be able to go query data from one of the other replicas of that data on a different machine. Right?
Okay, they have the replica as a backup.
Right, replication for for durability purposes, is handled by HDFS. HBase defers the durability question for the data to HDFS, and HDFS solves that by having the configurable but three-way replica by default. Yeah, so if one of their data nodes goes down, then the data is still sitting on another machine in the cluster. And HBase is able to go and reach out to those other machines to be able to service the queries that it needs.
I put that master.
The HBase master. It's sitting there outside of the data path, and that's intentional. There's no client involvement when you're going to retrieve data.
What happens if that fails or there is some type of problem there?
So if the master fails, the cluster will continue to hum along. What will not happen is the master will periodically be running a balancer, so it'll try to spread the load evenly across the cluster. So if data on one particular region server grows and grows and grows and grows until the region, I didn't talk about this yet either, but a region will split and then become two regions after it's exceeded a certain size. That happens during normal operations, right? So the master will periodically kick on and determine that maybe one region server has become too overloaded and will move regions to other region servers. So if the master is not online and available, then that maintenance of the cluster is not happening. But the cluster will continue to serve reads, right? The client can still talk directly to the region server to send reads and writes. Assignment doesn't change. But automatic healing of the cluster and balancing the cluster is unavailable in a period where the master is unavailable. You can run multiple masters as well. They'll just do a leader election, and the new one will pick up where the filament left off.
My personal experience is for some small company, maintain this Zookeeper infrastructure, this regional server, it's concerned with a huge overhead for using HBase. On MongoDB has some kind of nice online kind of service which really free the developer from worry about this replication consistent. Do you know any kind of similar like HBase? I can log in this website, boom, they manage it for me. Let's say I have enough money, right, to employ their service, so I can log in, create an account. Okay, I define my schema, use JSON, whatever, load in. They start to create this kind of structure, so I don't need to worry about this regional server. Do you know there's some similar service? Because I know MongoDB has something called Mongo LB, Mongo Lab, which is like you can have a free trial and you can monthly service. Is there a similar service like I can get rid of? I say I can set up Windows HBase, but if I want a big cluster, but I don't want to spend money, I don't have technical support. I just want to do the similar fashion. Is there some similar service existing?
There's no HBase as a service company that I know of. If you're
opportunity.
well aware of the market, maybe we can talk about that afterwards. There are ways to try out HBase if that's what you're looking for. I can take my Apache hat off, my Hortonworks hat on, and say HTTP. We have this distribution, and you can download our sandbox, for instance, which is a virtual machine that'll have HBase and all that stuff running for you. No support on the sandbox, but you can have it running locally. If you have an AWS account, you can. I think EMR offers HBase, so you can spin up an HBase cluster on EMR, and they don't manage anything for you, but it's the automation is all there, right? So that's provided through Elastic MapReduce, and I'm sure other cloud vendors do that thing as well. We don't have.
I noticed Cloud they give you an image, boom, you download the image.
Yeah, so that's the HTTP sandbox. Same kind of idea there.
But it's for toy,
Yeah, HBase is a little unique in the NoSQL family of databases because there's no dedicated HBase company. Right? Mongo has the Mongo company, React has Basho, Cassandra has the Cassandra company, but there's never been an HBase company. HBase has always been a community effort, almost exclusively. Right? The vendors, Hortonworks, Cloudera, etc., participate in those communities, but none of them are dedicated to just HBase in the way that those other NoSQLs have that kind of option. And I think that speaks to the way that HBase integrates into the Hadoop ecosystem, right? You use HBase as part of your Hadoop installation. So If you're just looking for a NoSQL, then maybe that's daunting, right? You're saying I've got to run these other services. But I find that having access to things like MapReduce and all of the tools that come along with it, and co-located and working very well and highly integrated into my HBase deployment is a benefit, right, that I don't really get if I'm using some of the other NoSQL options that are out there.
Yep. My point is this technology is very fancy, so we need to lower the bar. Entry.
I agree with that.
Entry
I think it
bar.
should be easier to use.
Yeah.
Patch is welcome. I'll commit anything that you've got to make stuff simpler. Absolutely. Absolutely. Yeah.
Did I understand correctly that data is local, the region data is local to the region server?
We try very hard for it to be local. Not always, but yeah.
So
When-
the region is moving, being split, then
Yeah, whenever a region server writes data, it writes a copy to its local disks and then other copies to other nodes in a cluster. So if a region is recently online on a machine, say it's been moved, reassigned to another, to this region server from some other region, maybe some of the data is on that local machine, not all of the data, right? So if you want to force having data locality, you can run a major compaction and it will rewrite, write all the data to the local, force local copies there. We're working with HDFS guys to expose APIs in that layer so that we can have more control over that and have the HDFS balance and move data to maintain HBase locality, but that's still a work in progress. Okay, we good on the physical architecture? We can roll into the actual title of the talk now? Yes? Great. What's that? Oh, one more. Yeah, okay. You might have to go get beers if you're going to keep everybody here, though. Okay, so major new features for HBase 1.0. What am I out here in LA, far away from home? What are we talking about? So one of the first things that I want to describe here is a feature with stability in mind. So there's plumbing work in the 1.0, upcoming 1.0 release to allow us to keep meta region co-located with master. So on that diagram that I just had up there, the master was sitting off to the side. It wasn't really doing anything except cluster orchestration. So this set of changes actually turns the master into a region server, and it will be responsible for hosting system tables. So I didn't talk at all about how the client finds which machine is hosting a region that it's interested in communicating with. All that stuff is handled by system tables in HBase. So by putting master next to the meta system, the system tables that contains all that stuff, we're I think eliminating a whole class of bugs and problems that you can have in deployment. So this is not turned on by default, and it's a work in progress towards some other improvements, notably reducing, having one fewer process to run, so folding the master into the region server itself, and so that way that there's not a separate process. All region servers could be potential or running as backup masters, as we described, and so simplifying. But if you're running in a highly volatile environment, such as like EC2 or an environment like this, there's a whole class of bugs that you will not have to deal with if you have this feature turned on. So for those of you working in EC2, not bugs, I mean HBase handles those scenarios pretty well. We've tested the hell of it. So, but there's problems that you can avoid and windows of unavailability and things like this that you can avoid with a feature like this. So again, the plumbing's all there. We're starting to test it with this release, but it's turned off by default. Yes.
So when you go to that master and region server, being now all region servers are master, all master are region server. What does the client discover all the table and all? Earlier it was talking to master. Now does it have to talk to?
It never talked to master actually to discover that. So I didn't go through data location or cluster service at discovery or anything like that. So the client will connect and it will locate the master through Zookeeper. Right, Zookeeper is used to look for the location of the meta table through Zookeeper, and then everything else is handled online directly by communication through that table.
So whatever is there any information that is stored in master table? Is there anything moving into the Zookeeper?
There's no master. It's the meta table. Is the system table that describes the location of the regions across the cluster. That's the case today, and it's not changing with 1.0. So all this is doing is making sure that the system that is managing updates to that meta table, the master, is sitting in the same host as the table itself. Actually, I have a slide a little bit later on. It's just a bullet there, but one of the other things that we're working on through this release is decoupling ourselves from Zookeeper, so making those interfaces pluggable and allowing us to explore alternatives to Zookeeper for just like Graft and alternative Paxos implementations and so on are coming. So for folks that are interested in some of the more academic side of distributed systems, we're working to make HBase more pluggable in that particular component, which is interesting academically and then potentially operational as well, based on other environments you might want to run HBase. Yeah, so any other questions about the distributed rigging bits? Again, off by default, but you can check out this ticket here if you want to read more about it. Yeah.
So if the master is embedded with the reading server, does the master now require a local HBase access, or can that still be housed elsewhere? Because currently, like we run our HBase master sort of on an edge rather than a cluster. Would you recommend changing that if we're going to enable it?
Yeah, you would. I mean, whether it's running side-by-side a data node or not, it's still using the DFS client API, so it's able to make remote calls. But yeah, you want to play with these features and turn it on, then I would collocate master with the data node as well, so that it has the option to have data locality and enjoy data locality and serving those tables as well. But really, these tables, unless you've got thousands of machines in your cluster or you've got millions of regions in your cluster, these tables are relatively small, and they're mostly sort of out of memory anyway. It's just the write-ahead lock that's hitting the DFS when edits come through. Big feature number 2, this one is called region replicas, and it's an attempt in HBase to provide a higher level of availability while maintaining our strong, consistent guarantees. So what this feature is doing is taking those regions that are hosted by region servers, and now instead of a single region server being responsible for the online availability of that region, now we're giving that responsibility to multiple regions. So in the same way that in HDFS you have 3 replicas of your data guaranteeing durability, when we turn on this feature, region replicas, now we have 3 copies or whatever you configure of your region available for on different region servers for increased availability. And there's a big asterisk caveat aside, going along with this, which is that this is providing, well, for one, it's read replicas only, right? So the primary region server is still responsible for hosting the region, so it's only the only one that can accept writes, and it is the canonical owner of the view of that region. But this allows a client who is okay with seeing stale data from their cluster to enjoy higher availability. So I've done a little bit of testing of this. There's more, in terms of performance, there's more work to be done. But in my testing, I've seen this drop the 99, 3 nines, and 4 nines. Those latencies come way down when you have more copies of the data available for read. Again, it depends on your application and your compassion or sorry, your acceptance having stale data returned back to your client. But for certain kinds of applications, applications where you maybe do writes in batch and then you're serving reads most of the time, this can be a very helpful feature for reducing the latency that is experienced by a client. Again, it's turned off by default, but the plumbing's all there, you can turn it on. We've actually been shipping this feature in HTTP since 2.1, the initial version, region read replicas. 2.2 will include, I think we're working toward the quorum-based writes, which will again increase availability. Those bits are shipped in HTTP, but this will be available in general Apache for the 1.0 release.
So what will happen? So what happens to the data locality of the replicas? Do they still have the data locality, or do they get it?
No, the replicas are there as essentially they're serving backup, right? So the way that this features implemented is they're all having data online, but because only one region server is responsible for writing data, when it's flushing its num stores, the data is going to be local guaranteed on that one machine. But what this allows us to do is in the client, it issues a request to the primary, and if that request doesn't come back within a certain cutoff time, it will issue queries to the replicas as well, and then whichever responds first, it will return that value back to the client. So that cutoff is configurable. You can set it, I think you can set it to 0 and have it issue requests against all 3 replicas at the same time if you want. But those other replicas are by definition not going to be able to have complete data locality in any kind of guaranteed sense. So they're going to be potentially be doing network reads. It just depends on how lucky you are. There was another.
Does this mean that if you do replicas at the region level, you're doing 3 times more on top of HDFS?
It's not a replica of writes. It's only replicas of availability, right?
Oh.
So there's now 3 servers that are able to serve RPC requests inquiring about a particular region instead of just 1 before. It does have impact on on the read machinery though. So the effective block cache size, so HBase has a structure called the block cache, which is an in-memory cache of data that it's read from HDFS. The idea is that if you're querying a set of a piece of, some row or something, a bit of data that's being hit frequently or whatever, HBase will keep that data in memory, and so other accesses that are hitting similar parts of the data set will likely benefit from that IO having already been performed for an existing previous operation. So when you have this turned on now, those replicas are consuming space in the block cache, so your overall effective cache size for the cluster is reduced. Make sense? Okay, more questions. In the back first, please. You had this hand before. Sorry.
What kind of delay do you have before you have inconsistency on these replicas? I presume it has to be after a sort of flush and then some period after that?
So I believe this is implemented, the replicas are tailing the wall. So when a replica region is opened, it will see all of the H files that are existing on the HDFS, and then it will tail the wall file, the write-ahead log of the primary for this, and make those edits that are in the wall available in its local node store for that replica region. Can't remember if it's wall tailing or if the primary is sending RPCs to the replicas. I don't remember that exact detail. It's one of those two, and it might be changing with as we move towards supporting quorum-based writes. Yes.
Okay. So I'm thinking if you could conceivably, it sounds like write a value out and immediately read get a different value.
Absolutely.
So is there
Different value than what you wrote. That's absolutely true. So you're opening yourself up to the modify write bugs that exist in eventually consistent systems. That's absolutely true. If your write operations are based on atomic operations, then it'll just fail, right? And you won't suffer. You won't be overwriting your own data. Yeah. So when you get your result back, there's a flag on it. What is the consistency level? It'll tell you if it's strongly consistent, if it's the real data, or if it's if you're experiencing your stale data, if you have a stale read. It might be the same as what is on the primary replica, but the system has no way to tell you for sure.
right?
I'm assuming you could enable this per table.
Yes.
Okay. So
Yep.
you might
Maybe even per column family, I think.
Okay.
Yep.
Talk about the memories in the cache.
Mm-hmm.
Is there some policy like, so I have lots of frequent read the data, so is there HBase has some kind of adaptive policy, like I know pattern my data being frequently read, so I can automatically to make my memory cache to preserve them, rather than is totally I don't have control at all. It's a black box. I don't know how the data get into that cache.
Data is cached on read, is how that works. So, and it's evicted on an LRU policy. So as new data is being requested and it's being served by the region server, if there's no more room in the cache, then it'll have to throw out something, and it chooses the oldest, least recently used data. Yeah, you can. There's a configuration. You can say column family or a table is marked as in memory, and it will get preferential treatment in the eviction process. But it's implemented right now as an eviction. Yeah. Other questions about region replicas? Yeah.
So, question. So, if I have a strong, consistent requirement, say like I cannot read any scale data or data, so that means I cannot use these features to achieve high ability because I always need to read the requirement.
Yep. In HBase 1.0, that's the way it is. Future versions were, like I said, we're paving, laying the plumbing work to be able to start doing quorum-based operations. So future versions of HBase, maybe a 2.0 feature would be actual quorum consensus for these things, and then you wouldn't have to suffer that. All right, and this topic is covered in much further detail in this HBase Con talk that's linked there at the bottom. And then finally, big in that it's been bothering me for a long time and it's finally happening, API cleanup around the client API. So this is not major new feature, this is not fancy new whiz-bang distributed system stuff, this is like good old-fashioned software engineering. You should really use an interface for that. You should really define methods that make sense, and use builder pattern, this sort of thing. So I'm very excited to have this kind of stuff going out, and so your existing applications will continue to work. Don't worry, we're just marking things as deprecated, nothing's going away. But the new audience is the new interface is a lot more hygienic, and I think it'll be nicer to develop against. We also have this, we've had it since '96, but we have this annotation on our classes called audience interface, and this is us, HBase developers, being explicit about what classes in the system we expect clients' applications to consume and which ones we don't. So if you've been just autocomplete through my class hierarchy to find a little thing that I'm looking for, it could be you stumbled into some classes that we consider internal and that we're not keeping in mind in terms of backward compatibility. So you can use this annotation in your build automation or whatever else to detect cases where you stumbled into that stuff that's not going to be publicly consumed. And then again, actually the whole talk on this topic by some of the folks, ironically enough, folks at Google have been doing some of the contributions to this work. So they gave a talk about this in more detail as well as examples, code examples, and so on. So that's available for you guys to check out.
So in here, you look at the client API really refer to Java API.
Yes.
You do have Ruby, Python, those things.
We have Java. It's still, and this is something else that I wish we had gotten to for 1.0, but it hasn't come through. Our client API is in Java. You can access HBase from non-Java clients. Obviously, you can use JRuby, right, if you want to use Ruby, but to interface with HBase from non-Java clients, we have two different interfaces you can use. We have a REST interface and we have a Thrift interface. Okay. So in either case, you'll stand up the REST gateway, the Thrift gateway, and then you'll be able to write your clients against those services. I think REST is more feature complete compared to the Java API than the Thrift interfaces. So I would start with REST if you're looking at a new greenfield project. Client questions? Once? Twice? All right. And then there's a bunch of other general cleanup and fixes and more things than I can talk about. I am particularly excited about our updated documentation. We have an online book, even as a HBase book author. I'm excited to have this online book because it's way more up to date than anything that I keep track of, and it's maintained by the community instead of just two guys in their off hours. So it's a lot easier, I think, to get started now with HBase than it was even 2 years ago, in large part because of the community effort to upgrade our documentation project. And more pieces along the way. If you're into this new Docker business, we ship a Docker file that can make it easy to pick up. I'm particularly excited about the compressed block hash. It's a feature that I worked on, so I'm excited to talk about it and talk it up. And then under the covers, we're doing a lot of adjustments, refactoring. I've already mentioned a little bit of the Zookeeper abstractions to try to loosen our dependency on that system. We're trying to make way for new features, new exciting features that users are facing for 2.0. And we've already gone through a lot of that work in preparation for the 1.0 release. Of course, there's always more work to do, but all this kind of stuff we've been like poking around with under the hood. And then, as I said, 2.0 around the corner, better, faster, stronger. There's plenty of new things that are baking currently for on the master branch. So if you're curious about any of these, I've been focusing a lot personally on the performance side of things because I think there's more we can do. But there's lots of stuff in progress. Like I said, the community's been growing a lot, and so we've got a lot going on. And then finally, Apache HBase development community, we're adopting semantic versioning for 1.0 release and onward. So what that means to us is that we're making a commitment in terms of compatibilities across upgrades. And you go from 1.0 to 1.01, what you can expect, what you don't expect, 1.0 to 1.1, and so on. So we're looking at this across a number of dimensions, including compatibility at a number of different layers. And so all of this is, it hasn't been quite set in stone yet, so I don't have a link to share with you guys, but it's on the way. Okay, so I'm running HBase now. How do I get to this new fancy business? So the first question of the upgrade is online compatibility. Can I do a rolling restart of my cluster to the new bits? The answer is you're still on 94. You've still got to make the jump from 94 to 96. But if you're 96, 98, you are a rolling restart away. And this is enabled because we have backward compatibility with our RPC layer. So our over-the-wire traffic is all compatible across client versions, server versions, and all that stuff. So you'll be able to just throw the switch and it'll all happen seamlessly, with the caveat that 1.0 is turning off some features that aren't available in 96. So if you're going the jump from 96 to 1.0, make sure you've disabled those features that we've turned on by default while you're going through the upgrade. Otherwise, you can get into some problems like maybe some HTML3s have been written that your old 96 hosts aren't able to read. So you can avoid some of those hassles by turning those features off. Our API is backward compatible to 96. Even the jump from 94 to 96 isn't too bad. The list of incompatible API spots is short. So no code changes will be required to your application. You'll start to see new warnings as deprecations have come in, so you'll be able to prepare yourself for 2.0, but everything will work out of the box. It's not ABI compatible, which means just like when you went from 96 to 98, you will need to recompile against the new jars. Otherwise, if you try to drop your 0.96 compiled application into a 1.0 or a 98 even runtime, you'll see some strange errors that are really terrifying. It's not really what it looks like, it's just you need to recompile. Hadoop 1 is gone. Sorry, if you're still on Hadoop 1, it's time to upgrade. You'll thank me for it in the end, I promise. We're drop support for 1.0 on Hadoop 1 on HBase 1.0. HBase will be most thoroughly tested, I think, on the 2.4 and 2.5 versions of Hadoop 2. It will run on 2.2, 2.3, but the major vendors are shipping against 2.4, 2.5, so that's probably where it's been most thoroughly tested and where you'll experience the least bugs. We have a compatibility matrix on our online book, that fancy new book that I was just talking about, online guide, so you can look in more detail about your interested combination of versions there. Likewise in Java, if you're still running JDK 6, I'm sorry, but the time has finally come. We're Java developers too. We want to get onto the fancy new stuff that is coming out in Java 8 and Java 9, so we got to start dropping support for the older stuff. So JDK 7 is probably where you want to be. Again, it's probably going to be the most well-tested version of, in terms of the community release of HBase, of the Java runtime. And also, like the Hadoop versions, we have this compatibility matrix you can check out. Okay, so I hope you're all excited about this new version of HBase that's around the corner. You don't have to wait for the release, it's not out yet. You don't have to wait. We started cutting developer previews. So if I had a link tag like in the old HTML Wonder days, I would have that not for production use blinking there in front of your eyes. But it's in big, bold, and capital letters. So hopefully you'll give it a spin, try out the new bits, check out some of the new features we've worked on, give us your feedback, help us test it, right? Like I said, there's no single company that's making HBase possible. It really is a community effort, so we need help from the community for big releases like this. So if you've got a test cluster, you're maybe curious, you want to upgrade, and you can spare some cycles, please let me know. Shoot me a mail or talk to me hereafter, find me on Twitter, whatever is convenient for you, and let's make this a solid release. The latest release is 0.99, and I think 0.99.2 will be coming out in the next couple of weeks. The release manager also works with me at Hortonworks, so we're still a little bit busy with our day jobs. We'll get to the release shortly. Thank you for your attention, everyone. This is what I got for you tonight. Like I said, I'll plug my book. Here it is. That's a discount code if you're interested in learning HBase. Despite all these changes, it's still relevant information. Questions about like schema design and so on, I try to address in there. So short of my talk, maybe I can convince you to twist your arm. Anyway, that's a discount code that'll work. And this is how you can find me on the web. And thank you very much. Any questions?
Can you talk about Slider? HBase on YARN?
What can I tell you about Slider?
What's the progress?
Slider is continuing development. I still wouldn't recommend it for production, but it's driving a lot of improvements, and those continue to go in.
Like, do you know, like, is it part of the roadmap on HBases, or
It's its own Apache project, so
Slider.
Slider is right. I know some of the Slider devs that I work next to. HBase is one of the reference applications that they use for testing sliders, so I think HBase deployments will be relatively well tested compared perhaps to other applications. But other than that, it's a separate Apache project.
What's the significance of your book?
I wish I knew. The publisher gave me 3 options, and I said, this looks the less dumb of the choices, and I kind of like the fish.
I noticed there is a concept called a coprocessor. Maybe the terminology is not, but the concept-wise similar to like a traditional database, like store procedure. So is that a similar thing? Is how this concept is called coprocessor significant to like a developer perspective?
For an average developer, the coprocessor is not significant.
Okay.
It's like I said, HBase is very configurable. Pretty much any decision that the system is making, you can override in some way. Coprocessors are an extreme example of that. I don't think of them like stored procedures in the database. I think of them more like Linux kernel modules. So if you were comfortable writing a new driver for your hardware, you can load that into your server at the kernel level, then you maybe are comfortable getting into HBase and knowing it inside and out enough to be able to write some coprocessors. That said, there's some interesting functionality that is exposed. That Apache Phoenix project that I talked about, the SQL on top of HBase, is heavily driven by coprocessor implementation. So the API is pretty well exercised in terms of stability, but we have very different guarantees about that API compared to the client API regarding compatibility and crawling upgradability and that sort of thing.
So for instance, if I want to do some kind of aggregator function, like I have this table, this is range, I want to give like average or something, some kind of aggregator. So the right implementation is using Phoenix or just writing?
Phoenix will give you that out of the box. I think I have an example module, and where we actually give that's one of our examples is an aggregation endpoint. So there's 2 kinds of coprocessors. There's observers and endpoints. An observer hooks in. It's like AOP advice, perhaps, in programming. So it hooks in before an RPC, after, during. There's different hooks along the way that you can plug into. So you can modify a read operation on its way out the door, for instance. The endpoint coprocessor allows you to actually extend the RPC interface of the region server, and you add new remote procedures that the client can invoke. And so things like an aggregation function can be embedded into the region servers themselves. Phoenix makes, like I said, makes heavy use of this. And what it ends up looking like for things like aggregation, you're doing a very simple MapReduce operation where you map the map set is spread across the region servers through the endpoint invocation, and then the reduce happens on the client side. Those results from all the region servers are aggregated back there on the client. Okay, go for it.
So another thing is, I'm working on some kind of military project. Their sensor data, their data is very sensitive. They need to know exactly who do the read, who do the write, as well lots of query. So is that component, is there something out of box I can put in there? I was thinking using this concept of co-processor. AOP, you say, so I monitor like, hey, who is this guy, what kind of role, and what he did in certain time. Is there some storage place I can writing down this access level information?
So HBase, secure deployment of HBase already has an access log that sounds like what you would want to use. You might experiment with implementing your own override of that thing or augmenting it, and perhaps writing that data into a system table, into an HBase table instead of log files, but we already have an access log.
If you look at the pattern for, and it'll be an ACV 2.2, but there's something called Apache Ranger, which provides a centralized user definition and also audit log capture. So I can create a user and assign them role-based access to things like HDFS, Hive, HBase, other components like Storm. They're all going to integrate to one view of how I define security. And so already it's overridden the HBase authentication plugin for Ranger. So any user that accesses HBase gets checked against policy in the Ranger module, and all of that activity gets logged. And it's logged into also, like, if you want to push it out to the SQL server for log collection or to log file or into HDFS, right? So your thing might be already just something you can install and configure and not have, getting into coprocessors is wading into the deep end a little bit. So,
yeah, I wouldn't recommend it for your first project.
It's not a starting place.
It's in the advanced
That's if you want to write your own
section.
encryption,
Yeah, some
your own
examples.
encryption type on a column or something, but not for
Doesn't
logging.
HBase already support tags? I mean, doing audit control, I thought that was part of the security features in 98.
HBase has shipped
So you
security
should-
since
you should be
92.
able to do audit control.
So audit, well,
Like you can,
yeah, I mean, I believe we've had an audit log for a very long time. I don't know exactly how long. What you're thinking about the cell level security,
yeah,
which
exactly.
is something we've introduced in '98.
Yeah,
That's much more granular, right?
yeah. So I think, I mean, wouldn't that be something that there's actually cell level security supported in HBase right now? So you can actually, keep track of who is access that particular cell at the cell level guarantee. So there's this thing feature
On a
called
per key
tags.
value kind of level, how this level of security, we had security earlier that was at a more coarse-grained implementation. So, and I don't know if our cell level access is audit is going through the audit log or not. That's not a detail I know. Yes.
Do you have any plans of adding secondary indexes in HBase?
There are, I think, at least 3 implementations of secondary indexes that have been floating around the GitHubs for a number of years. We as a community have not stopped bickering about which is the right way to do it and adopted any of them. That's why there's nothing shipped in HBase. If you have an application that is dependent on a secondary access kind of pattern, I would highly recommend you look at Phoenix. It has secondary index. Yeah, it has secondary index out of the box. I built it myself. It's hard to get right. I don't think I've ever gotten it right, actually, in a strongly consistent kind of way. Phoenix is biting that one off. So, yeah, I would look there. All right, thank you everyone for your attention. I appreciate it.
Hello. Hello. Anyways, I guess it's not working. Before we leave, I just want to thank Factual for hosting the event. They've been pretty good to us to host these events. They do it for free, and they bring the pizza, and also Aaron, who is out there in the back, just give him a round of applause. And thanks, Nick, for again coming down. I think you live in Seattle, right?
Yeah, Seattle.
It's a 3-hour flight or something.
Yeah. So and I gotta suffer the burden of LA weather too. So.
It's better than Seattle. Much more gloomy up there. So thanks again for coming. I'll see you guys next week.
Thank you.
What's going on next week?
Wednesday.
Where is it?
Have HBase clients swallow things?
Swallow things.
Like one issue where data we're expecting we're finding as you go look and look through the mappers, and HBase client is actually having a heap violation, killing itself, swallowing the eyewear, but we still got data back. It's what it could, and it died.
I got out of memory, and MapReduce killed the job. Right? The process would have died. You're running from MapReduce. Yeah.
They're not using
No, but
MapReduce.
MapReduce didn't die. The client had a heap of space violations. It saw that, but it caused that IO error, and it killed itself. I know it happened. Whatever comes to the
Yeah, that would be surprising to me. I mean, I remember issues. Catch those exceptions very soon. As far as it's kind of thrown out, it's died.
Mind if I send you? I think I might still have.
Yeah, the access died.
What you said about that. I presume your slides are going to have your. Are you have slides up?
Slides are again.
We were having some performance issues, and it turned out, finally found out I2 had a problem where the two-keeper connection failed. The two-keeper kept dying, which caused it.